Hello everyone. I hope you're live and you can hear me properly. If so, then welcome to the last session of today's list of sessions. I'm Peter L., also known as the mathematical notation for the Turing machine. And I'm going to talk about a new programming language that we are making called Draco. First off, I've put a little QR code here and a short link for the presentation. I'll have quite a few links all around for little details that I don't have time to go into. So if you're interested, feel free to check them out. I also intend this for this to be a high-level overview of the project, of what our goals are. If you're interested in internals, how the compiler works or is intended to work, then there will be other channels of discussion for that later. So first, who are we? We are a small community of .NET users who really enjoy using C# in our day jobs and for hobby projects. And we also love what the platform gives us. We love the ecosystem and the amazing tooling that we get. All the editors, NuGet, the packages that the community develops. But we also see the room for improvements when it comes to the language. We also do not have any affiliation with Microsoft. We are completely independent. And just a small note here, before I bring up any code examples, that beauty in the language is very much a subjective topic. And when I claim something is not right, you don't have to agree with me. You can approach me, we can have a discussion, and we can learn from each other's perspectives, because language design, turns out, is really hard, and it's a really deep rabbit hole that you can get lost in. So first off, I would like to clarify why we want to create another programming language for .NET. So first off, this isn't really a reason, but something that will lead up to reasons is that C# was born more than 20 years ago, which means that it has a lot of accumulated features, and it starts to linger around, especially in the later updates. People tend to call it bloat. I think bloat is a very unfair criticism. I think the designers do their best. They're doing amazing to bring out the most from where they started and where they want to head. But undoubtedly, it has become a fairly complex language with many features which might interact weirdly. It also has to be backwards compatible, which means that once a feature is in, it might block some other feature, or it alters the possibility for a feature in some way. And undoubtedly, there were some warts, bad decisions, or missed out features that had to be patched later on. Second, our idea about software development changes a lot. Especially lately, our paradigm shift has gone from a very object-oriented style to a more functional style. And we see that with less inheritance, more usage of link and other functional interfaces in C#. We have a bigger focus on external extensibility. We like these plug-and-play solutions instead of bringing in big inheritance hierarchies. And it turns out that we really need meta programming, so much so that we used Fody a while back to weave stuff into the IL that we need. And we also got source generators quite recently, which is an amazing addition to generate C# source code. So one other reason is the C heritage. C# is in the C family, so it inherited some things that C said that it should be that way, and we didn't even think about if it's the right way to structure a language. For example, all our control structures are inherently from C, and the old style switch, I don't know how you feel about it. I think it's awful, and I'm really glad that we got the switch expressions, for example. We also got the numeric type names that I'll talk a little bit more about later. I'll have a slide about it. We also inherited how enums are just magical numbers wrapped up as a separate type that could be way more, actually. For example, the language Rust brought out a lot more in enums than what C or C# did. And of course, the way that void is special is sometimes really, really annoying, that I'll have a slide about in a second. So there are quite a few edges in the language. For example, void is a special snowflake. If you've ever typed the func void, then you just remembered, oh, I need action for that, because void for some reason can't be typed where a type can be. It's like a no type type. Also, we have certain qualifiers that we can't specify, for example, ref in or out before a type, which might be a rational thing, but the type system doesn't allow for that for some reason. We still need delegates when we want to specify a function that takes a ref, an in or an out parameter. Also, it's not uncommon to see a unit type being thrown into a project, because it's easier to write fluent code when you don't have this special void all around in your project. Another one I hated when I first saw this is that we have regular functions and we got lambdas, and they are slowly converging to have the same feature set. Lambdas are essentially intended to be stripped out methods without a name. But as you can see, we have an inconsistency in the syntax, where for lambdas, you always need the arrow. But for methods, you only need it for the inline expression one. When I saw this, I started to hate it so much because I can't not notice it anymore. So another edge is how we have inherited all the numeric type names from C. And we standardized these to mean 8, 16, 32 and 64-bit integral types. And as you can see, there is an outlier here, especially Byte and SByte decided to switch around the naming convention. We also have weird value type conversions. For example, you can do this with an enum, where no matter what enum members you actually specify with whatever value, you can always assign 0 to it, but you can't assign any other integer value to it. This is because of some old heritage from default initialization, as far as I'm aware, but it's an arguable avort, nonetheless. We also have quite a few overloaded language elements. For example, type hinting, downcasting, and conversion are all under the same language concept, which we just call casting. Here I brought you an example. I just defined the base and the derived class, and the derived class has an explicit conversion operator. And below that, you can see a small program. The first line is actually interpreted as type hinting, so that will instantiate the derived type, and the type of hinted will be actually derived. Then I use polymorphism to assign a derived type to asBase. And then you can do downcasting with the same syntax, essentially. And then finally, you can actually do a conversion when you invoke the user's conversion operator. And this is all done with a single language concept that we call casting. I know many people will be mad for this. Still no discriminated unions. We have so many result type implementations in projects, or little polyfills like one-off, which essentially tries to emulate discriminated unions in one way or another. And this is sad, because nowadays what I see is that discriminated unions are the primary reason for inheritance, or class-based inheritance, I would say. And what workaround we do, we get no exhaustiveness check, which would be one of the biggest benefit of having discriminated unions in the language. I would like to specify that these might seem minor things, but they do add up. They do increase the cognitive complexity when working with the language. I would say it's sometimes even annoyance, especially when you want to generate C# code and have to work around these corners. And we also have to introduce a few workarounds here and there. For example, the custom unit type or emulating DUs somehow. So let me try to talk about our language philosophy, which a lot of people were actually interested about. So the essentials, we want to keep strong and static typing, because I believe that as a developer, types are your best friends. They are your best friends when refactoring, when compiling. So be happy for your type errors. Be happy that they are there for you and prevented a runtime error for you. We also aim this to be a non-academic language. We want this to be used by regular .NET developers. No any fanciness, any very new research going into this language. We also want to provide very strong tooling, because that attracts a lot of people, and of course that makes development a joy. And we also want to prefer general and stronger abstractions instead of small patches in the language that slowly add up into, well, you could say bloat or corners. And we want to add more worked-out features slower than an underspecified one that will need workarounds later on, which, for example, C++ was guilty of for quite a few of its additions. We also want to provide very good C# compatibility, because the ecosystem is very beautiful. And we don't want to actually replace C#. We want to succeed it, and we want them to coexist even in a package, later maybe even in a single assembly file. And finally, as an engineer, you just can't throw away 20 years of work. That's not really plausible at this point. We need to provide good compatibility to succeed. We also want no, or at least way less edges in the language, which first of all simplifies automated code generation, which is very important for one of our later goals. It also reduces the cognitive load that you need when using the language. I believe that it makes the language more predictable when you use it. You don't get weird corner cases or interactions. And one of our approaches that we are trying to do is that we give you less but way more powerful features instead of giving you a little bit of everything. One example of this is our string literals, which were ripped straight out of Swift. With only these two kinds of string literals, we have covered basically every kind of string literal that C# currently has, including row strings. You can arbitrarily extend the delimiters to have any multi-line string you want with any escape sequences you want. You can actually use the hash character to extend how you escape something. You use interpolation by escaping the open curlies, so no separate string type for that either. And these hash extensions can be used for both line and multi-line strings as well. We also have the unit type, which is essentially our void, but it's actually a unit. It's actually a real type. So you can specify it in generics, but it can also interact with C# void. So if you pass in, if something returns void in C#, we automatically map it to unit for you, not need to handle this yourself anywhere. So it's technically not even illegal to declare a variable of type unit, but you can't do this with void in C#, for example. We also made most things expressions, which is something that we brought from functional languages like F# or even Rust, for example, which means that you need way less language constructs, because now your conditional operator is just your if-else, your usual branching construct, and you don't need a separate switch structure for statements or expressions. You just have one. We just have one match expression that can be used as a statement as well, even with blocks, because blocks are expressions themselves. We also aim for external extensibility, which means that we want to be able to extend the type, and not just the way inheritance does. And we want more than extension functions. What we want to be able to do is to take any type and say that, hey, this type now implements this protocol, and we'll have these extra functions, and you can do polymorphism with it and stuff, which is essentially the idea, for example, for traits in Rust. And with C# 11, traits are almost like interfaces now, with the exception that you can't implement them for non-owned types. But as far as I know, this will be somewhat resolved with the roles proposal. This feature took heavy inspiration from Rust and OCaml. And for example, one thing that I would like to point out is that the CRTP that will be popping up soon with static abstracts is eliminated with the implicit self type. We call it this. Rust likes to call it self. We decided to stick with this because C# uses it. And on the right, I brought a small example of how this could look. You will declare a trait, you give it some functions that it implements, and then you implement it for even a non-owned type, like the primitive integer, 32-bit integer. We also want to give very strong metaprogramming capabilities because it's one powerful tool to do two things. One is to deduplicate code that you can't really wrap your head around or can't grab it with a nice abstraction to eliminate. And it also eliminates the need for language features that you might use in one or two niche cases, but otherwise would be a useless addition for the language itself. And here we want to take a very different approach to source generators, because we want to give the ability to modify or decorate code. So not just add, but to modify, even erase and stuff. But we want to introduce other restrictions to make this a feasible goal for us. I'd like to talk a little bit about planned features. A very small portion is actually implemented, so this is all just planned. Many of the things here are not even specified in the specifications, so let's go through them. First off, we want to have discriminated unions with the first version of the compiler. Because, as mentioned before, this is a reason for inheritance in so many cases now. We want to provide exhaustiveness checks, so it would be a very safe feature. You don't need to throw in the default case like you do nowadays in C# to make the compiler shut up. And it would be a data type that you wouldn't be able to extend externally, because it would be somewhat like a sealed hierarchy for C#. We also plan for a very powerful trait system. The formatting is awful here, I'm sorry. I don't know why it decided to break the lines like this. But traits would be the analog to our interfaces essentially. And the primary goal here is to promote external extensibility. So you define a trait, you can implement it for non-owned types, and you can even provide default implementations for certain methods. So you can essentially plug on many features if you can rely only a few that implement it. In C#, this is a bit more painful because default implementations for interfaces require to view the type as the interface type itself if you've tried it before. Here I try to bring an analog of how our traits and in C# interfaces would differ. And as you can see, we have the implicit this type, so no need for CRTP like in C# or even C++. Our next very big feature is macros, which I am the most excited about. It's very heavily inspired by Rust. It's not a scary text-based macro system like you heard in C. This would be actually a very clean abstraction, and it would be one of the most powerful features of the language. And it would be essentially a feature to implement new language features without them being written in the compiler itself. And we are planning for 3 flavors of them, all of them taken from Rust, because I believe that Rust did beautifully here. One is called derive macros, the second is attribute macros, and the third is method-like or procedure macros, if you like to call it like that. I'll have a slide about each on the next slides. But under the hood, they will be all the same. They would take the syntax tree of a language element, and it would give you the opportunity to transform it into something else and substitute it, essentially. So this is the idea. You would write a function that takes in the abstract syntax tree. This would be executed at compile time, transform your tree, and you return whatever your macro essentially expands to based on the input. So you can just write one yourself. There is no magic in the language in that sense. So first off, we have derived macros, which are decorators over language elements. They're like attributes in C#, and we are planning to do the same metadata kind. They would be just attributes that the compiler interprets differently. They do not modify anything, they add to the implementation. So derived macros add stuff and could never erase anything in your code. The example I brought here, again, formatting is ruined, I don't know why, is that you derive hash code, and that when that macro runs, it generates the implementation of the usual hash code combine call that you would do for this type. There's also a link for the full example of how you would write this macro yourself in the language. The API that we have brought up there is very just an initial thought. It's nothing final yet. The compiler is not yet at that stage, sadly. We are also planning for attribute macros, which are, again, decorators over the language elements. But they can completely alter the element itself, which means that you could even erase it and paste something completely different there. As an example, I brought here your usual recursive Fibonacci function, and it's annotated with the macro cached. And under the hood, if written correctly, it would output what you can see on the bottom, which creates a dictionary as a cache. And it would try to look up the value. If it's not present, it would just invoke the computation, then cache the result. And with this, you would essentially have linear time Fibonacci function, but just by memorizing the results as computed. And finally, we have method-like macros, which are invoked with a function call-like syntax. And the idea of this is that the call is essentially replaced with the generated AST. So it's just a replace macro, essentially, that you can use in expression context. For example, this can eliminate the need for, well, what I brought here is that you can eliminate collection initializers, and that you need to write an add function for your collections to work with the brace initializers. I brought a variadic macro that can just add each element for you and then return it in the block. On the right here, you can actually see how even blocks are expressions in our language. I would like to show you some samples finally, which are very much incomplete because, again, specification is very tiny. And language design is a lot of back and forth. And we have a day job and family, so we can't do this full time. So we couldn't make all the samples work yet. In fact, I think only 2 run currently on our compiler, but we'll see. First off is the truth machine, which is a very usual thing to showcase for, well, esoteric languages primarily, but it's an interesting thing to show off the very basics of a language. It just reads input. If the input is 0, it will output 0 and terminate. Otherwise, it will infinitely loop and output 1. And here it's shown what our current modules proposal is, which is very similar to the JavaScript, TypeScript, and the Rust kind of module system. It's not merged yet into the specifications, but this is the most liked one so far, and it showcases how you can actually interact with the C# BCL itself without any efforts. We are also planning for function local type inference, which would mean that inside a function, you don't need to type most of your things. It can be inferred from context. Here I brought a very little example where you construct a list, and you don't specify the generic arguments yet. But once you add something to the list that you know the type of, it will be inferred to have the proper generic type. This is very similar how Rust does it. So if you're familiar with the Rust type inference, you can imagine something very similar. We're also planning to give you the ability to derive common interface implementations. I brought it up with derive macros previously, that you can derive a trait or interface implementation, which means that you don't need IDE-generated code anymore that you would need to update regularly if you change the type. You don't need new language features to be able to generate this implementation. For example, you don't need records, because records can be just a type that automatically derives equality, hash code, and toString, and you essentially got the semantics for records. And this would be applicable for many, many traits or interfaces, going from equality, comparable, hash code, toString, even cloning, like deep cloning. And if you write a trait, you could actually provide your own default implementations for your users very simply, and just making them write a derive on top of their types, methods, whatever, and you implemented the feature for them. I would like to talk a little bit about the status of the project, which is which will be quite disappointing, but I hope I can encourage some people with this. So we're at the very beginning. We have been at the project for a year now, the specification part at least. And my excuse is that language design takes a very, very long time. And a very small but very committed community has already formed around the project. And recently we have actually started working on the compiler and tooling. So everything is super work in progress, but we're actually moving quite fast for our beginnings. First off, we have a GitHub organization where you can find most of our stuff. It's free and open source. Contributions are always welcome. First off, we have an ideas repository. And just a disclaimer there, our ideas repository is not 100% the specification. The issues that you find there is random dump of ideas, which I like it that way. I have a lot of nodes there that I like to read up, even for non-Draco related stuff. If you care about the actual specification, there's a folder there called appropriately named specification, and you will be able to see that it's actually very tiny. And we have a few unmerged RFCs coming up to the specs, actually. We also have the compiler repository, which contains the main compiler, the editor integration that we have started, and even a web IDE that I will talk about in a little bit. Links are here. They're clickable, I hope, if you have downloaded the presentation. But if you ping me anytime, I'll link it to you. So we have a web IDE, which is a very exciting feature. One night, one of our wonderful contributors decided that they didn't want sleep and decided to just compile the whole compiler using Blazor, and used the Monaco, which is the same editor behind the Visual Studio Code, embed it in the browser, and made Draco code run. And since that night, there have been added theming options. You have the option to run, see the compiled outputs, and it even has shareable links like you have for SharpLab. So you can just copy paste the link, and you will get the same source code as the person who sent you the link. You can actually try it out. It's very much work in progress. It's not using web workers right now, as far as I'm aware, so it's a bit laggy when you type, because it tries to compile the whole code synchronously and stuff. But it's a start, and I do think it's an amazing tool to have early on. We also have a VS Code extension already, which has syntax highlighting, and it also has a language server behind it. So you also already get very basic error reporting. For example, I brought here a syntax error being reported, and a symbol resolution error, which is how far the compiler gets today, actually. we do not yet support type checking and stuff. We're working on that. We also have a Discord server, which is our primary way of communication. We do language design there. We also plan to design the core library there. We do most of the compiler development there. I mean, the talks, and we communicate there what's to work on, which issues, and we also talk about the tooling that we're developing there. It's very awesome people with very diverse expertise. So I encourage anyone who wants to get into language design or even contribute to join us and have a discussion there. Finally, I'd like to talk about our plans for the future very quickly, because we're running out of time, I think. So we have a lot of problems to solve because C# compatibility is for us very important, but it can also hold back a lot of features. And this creates a lot of back and forth between what we want to implement, what we want to hold back, what we want to change. But our features also have to be tooling friendly, which is actually a very big challenge when you think about our macro system, which is, well, sounds nice, but it can also be the killer for tooling. So we have to be very careful about what we decide about that. And there are also platform constraints. So we can't forget that we are working with the .NET platform, the type system, the module system. So we can't just have arbitrary language features there. We need to complete the specifications, which is quite sad, because the actual specs is very minuscule, and you kind of need to specify the language to be able to build something around it, something serious. And currently, we're trying to see if prototyping helps that, if it speeds up the progress of deciding something or deciding against something. And well, yeah, it's hard to decide on a lot of things, mainly because of C# compatibility, and the other big factor is our chosen philosophy, which is going as perfect as we can, which doesn't really help, because achieving perfection is impossible and will waste a lot of our times. We need to release the compiler, but the compiler misses a lot of features, and it's probably not too hard to crash currently. We have most of the language features missing, even ones that are specified already. We have missing semantic correctness checks. We only do symbol resolution. No type checking is implemented. Work on that will begin soon, hopefully. And we are also planning to do an optimizing compiler. We're planning to do vectorization, which Ryu is missing out currently on, but we would like to add that ourselves. And of course, we're missing tons of user testing. So if you manage to break the web IDE or the compiler itself, good job. Please do report it to us so we can fix it. Eventually, we also want to self-host the compiler, because we want to have Draco compiler in Draco itself. And the plan is that we incrementally rewrite the current compiler, and we can use this because we are planning to have C# compatibility out of the box. So our current compiler is actually not a one-time affair. It's a real compiler work with real problems, with real things to solve. We're doing things the hard way instead of the easy way, because this will allow us to have a better experience supporting Draco, hopefully. It's also good matureness test for the compiler, and it's also good feedback for us about the language itself. We also need to write quite a bit of tooling, because lots of editors already have LSP support, so it's a very nice way to support many editors relatively easily. We already have started on the language server, so we need to write many language clients to be able to plug in to those editors. We also have basic syntax highlighting in terms of TextMate highlighter, but there are a couple of other formats that we would like to support. We also haven't started anything about the debugger. A formatter is actually currently work in progress. We will need stuff like linter, and in short, tons of work ahead of us, and we're very excited about it. And with that, I've hit the end of my presentation. So, any questions? Let's see, I'm bringing up Discord right now and see if I can spot any questions. Okay, we have one from Brainiac. How many persons are right now working on Draco, and is there a roadmap? Currently, there are 4 active contributors, I would say, who are working on the compiler or some tooling or stuff like the CLI. About the roadmap, we do not, and that would be something very, very useful to have later on. So that should be something that we should address soonish enough. Okay, question 2. Couldn't see the mention of I/O. What the current state plan pseudocode on that? Thinking async await, not even threads. But okay, so actually, there's been a quite big debate about async await on the server. My stance on that is that I currently do not know how we want to handle async await, and I do not know if I even want to ship the first version of the compiler or the language with async await. I know that this is something very much required in modern times. But I just haven't found a design or haven't seen a design yet that I'm happy with currently. Do I require additional funding for more intricate language development purposes? No, currently my day job supports all my expenses, which is only the domain name that we're currently paying for. No other expenses needed to be covered currently. It would be fun to have enough funds to not have to make the contributors have a day job. That would be awesome, though. Are tailcore optimizations planned at all in Draco? As far as I'm aware, C# doesn't do it, or I don't know, Ryu, because Roslyn itself doesn't do a lot of optimization itself. Yes, TCO is something that would be very useful because we are trying to push into a little bit of a functional style, which allows recursion a lot. Do you believe this language could be integrated into C# natively in the future? I do not exactly know what you mean by that, as in being able to call Draco from C# or C# from Draco. The answer to both is essentially yes. If you mean like scripting, then we already have a very minimalistic scripting API being worked on, so you could technically invoke it from C# that way as well. Any plans on providing grammar specs for Antler? Currently not. Currently the parser is handwritten. I've prototyped grammar in Antler before, but decided to drop it because error handling isn't very fun with a generator tool. But if there is a need, we will provide a grammar, no problem there. In the future, how would you evolve the language without bloating it? See what happened to C#. That's a very interesting question. And for that, my answer is that we have tried to get to the root of the problem, which is not giving you the powerful features early on. And we are trying to do that with macros and such. So that's how we are trying to fight the bloating. I'm not going to say that bloating won't happen in the language if this becomes a very long-term project, but I'm hoping that we can delay it a bit further, or at least have a fresh start compared to C# in its current state. What will be the practical usages of this language apart of new features? Will there be a focus on certain fields? No, this aims to be a general purpose language, just like C#. So the aim is that if you're planning to write new code on .NET, you might as well choose Draco if it suits your style better. Question, generic question, since I'm not familiar with language design, but how exactly do you tackle robustness and testing around the compiler? So that's a very interesting question because there's very little literature or anything about testing a compiler, well, a real-world compiler. One of the ways is to just throw a bunch of code at it and see if it fails. Currently, we're testing our parser and lexer very rigorously. We also have mutation testing currently. to see what's being untested in the compiler, well, at least in the lexer and parser. You can also do something called fuzz testing to see if it can crash your compiler. So yeah, there are a bunch of methods, and you apply them as the need raises. We don't do any formal verification, if that was your question. New language in order to deal with later tab spaces, or do you think linting formatting should be forced upon, but also, of course, user customizable? So, yeah, we actually have a lot of debate around C# formatting, because I have a very particular style that I really don't like to break in the repository. So we have mini wars around that. We are planning for very good tooling support, and that includes a linter and a formatter. We want to give a bit stronger hints about what's the ideal way to format code than C# does currently. But we also want to make it user customizable. We don't just want to say this is the way to do it. What is your philosophy in breaking backwards compatibility over the lifetime of the language, particularly to balance development velocity and perfect as you can design? This is a hard one as well. There will eventually be a time where we have to choose between backwards compatibility and the new awesome language feature that could replace. And currently, I'm happy I don't need to tackle this problem. I would say that sometimes it's very sensible to have breaking changes. And as far as I'm aware, a few languages actually do that from time to time. Not like Python 2 or 3, for example, but languages like Odin have restrictions and additions all the time, or even changes, and they successfully bring out these changes into the language specifications and the compiler, and they can bring you great update plans to your code. Admittedly, Odin is not very widespread yet, so it's not a huge scale test like you would have in C#. My philosophy is that if something really has to be broken, it can be broken, though I would do it in a step of few versions and not from one version right to the other. Questions. Am I a tabber or a spacer? Definitely a spacer. I don't really use tabs for quite a while now, and I like it this way, to be honest. But that's just my personal take. Your editor can choose for you and switch between the two in one click, so do not worry about that. My piece of advice here is that just be consistent, and if you're consistent, then you can make the changes if you need a style change anytime using an automated tool, or heck, even from the start, just set up editor config the way you're happy with it. And if you decide to change later, you just change a few lines and let VS carry out the changes for you. When can I write my lovely minimal APIs with Draco? So, ladies and gentlemen, we have our first banned user from the language. What are some good introductory resources for people interested in trying to develop a compiler language? Okay, so there are quite a few good resources. Sadly, they weren't around that much when I started to learn language development. I would say that one of the best introductory material currently is Crafting Interpreters by our great guy Bob, who wrote Game Programming Patterns, as far as I know. And that's a very good introductory material. It takes you through how you write a bytecode compiler for a very Java-like language. It's very good in some aspects, lacking in others, but as far as I'm aware, our introductory material is very lacking in the same aspect, which would be how you actually do tooling integration or type checking and such. Okay, any more questions? I do not see any yet. How are we with time? We have 1 minute left. Okay. So if no more questions, then thanks for joining me. I hope I got some of you interested in Draco or even in language design itself. If you ever want to create a language, even for just a toy, feel free to ping me for resources, for questions, anything. Okay, I got 2 more questions. Okay, why call it Draco? We had a vote on the server where anyone could recommend a name, and I guess my profile picture made people think I love dragons, which I absolutely do. So the choice became Draco because it's Latin for dragons. What stance does Draco take for language APIs that are effectively duplicates? C various implementations of timer. So the base cost library is something that is we haven't really talked about yet. It would be really nice to eliminate duplicates, but of course, if we are planning to be able to interop with the C# BCL, we have already lost. We have lost that fight, but for our current plans, the BCL, the extra stuff that we are planning to ship with the compiler, we are going for very dry code, so we do not want repetition very much. Okay, so if there are no more questions, then thank you very much, and have a wonderful rest of your conference. I've certainly enjoyed all of the talks so far, so see you on the rest. Goodbye.